Okay, let's say that we have a wire and through that wire we have some current, and let's say that we want to calculate magnetic field, let's say in this point here. How can we do that? How to derive a closed form formula for magnetic field? From experiments, we know that magnetic field is proportional to current to that wire, but inversely proportional to the distance r from wire to that point. We also knew that, for example, if we put, let's say, the magnets around that wire, they will line up with imaginary circles around that wire. So which means that magnetic field direction is, let's say, perpendicular to, let's say, imaginary line from that wire to that point. So it's look like this. And let's see what we else know and what else we can use to derive formula for magnetic field. We also knew that, for example, if we have a let's say conductor, and on that conductor we have, let's say, negative charges. We also knew that electric field is inversely proportional to distance from that conductor. And this R, actually, it's because each individual charge contribute with R square in this electric field. And but the thing is, we have electric monopoles, but we don't have magnetic monopoles, and this is, it seems that it's not going to work, right? But let's think a little bit. So what we can do, we can cut this wire in small pieces, let's say dl, and then let's say imagine that we have small magnetic monopoles which will each contribute to this final magnetic field in this point. So let's say that we have dl, and through that dl we have some current, and on this point here we want to calculate magnetic field, and of course we have this here. We have actually this is a vector here. We just point in that direction toward this point where we want to calculate magnetic field. So what we have then is something like this. So we have that magnetic field is okay, it's proportional to current through that wire, right? It's inversely proportional to distance square, and of course we have dl, right? And yeah, but this is not correct, right? We know from experiments that actually the direction of magnetic field is perpendicular to this imaginary line which passes through this point, right? So we need a cross, yeah, right, here with unit vector. And of course we need one more thing. We need one more constant here, and probably you're wondering why we need a constant. Actually, we need this to make things right. For example, magnetic field will not be the same if we perform measurements in vacuum or in the air. And these constants, of course, can be actually derived by performing experiments. So it's mu times divided by 4 pi. So this is it. And now you probably wondering, asking yourself, okay, why is this true? Well, scientists didn't know is it true or not, is it working or not. They just had idea how to derive that formula, and after that they perform experiments, measurements, and it turns out that this formula actually it's correct. So they had some ideas how to derive that formula, but after that you need to perform experiments and measurements to verify that is it true or it's not. And one more thing, you probably asking yourself, okay, why r squared? Well, the first, actually, the Newton was the genius who came to that idea to use r squared first for formula for gravitation, then for electric field, and then scientists, had idea, okay, if it works for gravity and for electric field, maybe it will work as well for magnetic field, right? And it turns out that that idea was correct.